Malcolm Drilling was approached to take over the foundation piling for the new Benicia Bridge in Martinez, California, after a series of problems and geological change conditions caused the general contractor to fall over 2 years behind schedule and over budget. The new bridge will be built next to the existing railroad trestle. Due to the heavy increase in auto and truck traffic, this portion of Highway 680 has become a bottleneck of horrendous proportions. One of the difficulties on this project is that most of the piers are out on the water. Everything has to be either barged in or come by boat. This takes time, and therefore you have to have thought out every possible conceivable scenario. Just to move anything, big or small, takes time. It has to be loaded with a huge crane and put onto a barge and pushed out to the platform. Everything takes time. Everything moves slowly. These huge temporary platforms have been specially constructed for this job. They measure over 100 feet by 100 feet and rest on 8 to 9 8-foot 2-inch diameter piles going down into hard rock some 175 feet. The size of the equipment is huge. Everything out here is big. The lever rotator weighs in at over 253,500 pounds and has over 5,400,000 foot-pounds of torque, as well as over 1 million pounds of extraction force. Due to the depth of these holes, some going over 300 feet through the water down into the rock socket, the weight of the casing is enormous. The full string will weigh over 308,000 pounds. Each casing is 25 feet long by 7 foot 2 inches in diameter. As the rotator grips the casing, it forcefully twists while pulling the casing downward, while the teeth on the cutting shoe cut through the rock. Then the rock is chiseled and broken and finally removed with a lever grab. Here, the upper centralizer is being moved from one hole to the next hole. It is then welded to the permanent casing. This keeps the rotator casing aligned within the permanent casing. Here, we see the workers changing some of the worn teeth on the starter casing as they prepare to couple the stored casing string to the starter. Once the starter is ready to go, the 150-foot string of casing is lifted clear of the temporary storage hole. Each section of this casing is 25 foot in length and is connected to each piece by the use of 20 large connector bolts. Slowly and carefully, under the watchful eye of the veteran crane operator, the casing is carefully maneuvered out of the storage hole to be connected to the 22-foot starter with large conical bolts. This long drill string of sectional casing will be set down into the permanent casing. The permanent casing has been previously vibrated down approximately 170 feet into the bedrock by the general contractor. Once driven to the starting depth, the platform was put in place over the permanent casing. Malcolm Drilling then places their drill string into the permanent casing and will drill inside this casing down into the specified rock socket depth. These rock sockets vary according to the specs, but they are from 67 feet to some nearly 150 feet deep. Now, the lever chisel is being inserted into the casing. It will be lowered to within 6 foot of the hard rock and then repeatedly dropped to bust or fracture the rock. This chisel weighs over 33,000 pounds. Now, the crane has been hooked up to the 47,000-pound LKG3 spherical grab, which functions like a giant ice cream scoop. It is inserted into the casing and then grabs the broken or fractured material which was broken earlier by the chisel. It forcefully closes on the fractured rock for removal from the casing. As the lever spherical grab clears the casing, it is slowly lowered into position over a specially constructed 25 cubic yard dumpster. The spoils from the casing cleanout are then dumped into this container. When the 25-yard dumpster is full, it is emptied into nearby spoils barge. Success! The grab has completed a successful pass, removing 2.5 cubic yards in one bite. A Malcolm employee has just disconnected the lifting helmet from a specially designed trimmy pipe string that is being used to airlift spoils from the drilled shaft. Up 15 feet in the air on top of the rotator, the men are about to hook the lifting helmet onto the next section of pipe to be removed. The trimmy has 3 sections here that are 50-foot long each, plus 4 that are 25-foot long. When the full 300-foot length is deployed, it weighs over 8 tons. Here we see the huge reinforcement cage for the next pile. These cages are fabricated in Vallejo, California at the general contractor's yard. They are then carefully loaded onto a specially constructed barge that has a pivoting carriage that supports the length and weight of the cage. This is called the tipping barge. You can see the cage as it is slowly lifted vertical with a heavy-duty chain, and below the spreader bar we see 2 blow scoom blocks attached to a running line sling that facilitates the lifting process to position the cage upright. Ever so slowly and with extreme precision by the crane operator, the cage angles skyward. The men at Malcolm Drilling have affectionately dubbed this piece of equipment the rocket launcher. Now, nearly vertical with its base 6 feet underwater, the 210,000-pound cage is slowly maneuvered free of its carriage and slowly lifted to the storage hole for safe keeping until the next pile is drilled and cleaned out. Ever so slowly, the cage is lowered. Here you can see to the left of the lever rotator the huge cage residing in its storage hole. Malcolm employees are now connecting the lifting shackles with this large pin to the picking head. Under the watchful eye of the crane operator, the 210,000-pound cage is moved skyward from its temporary storage hole. The long white tubes you see running the length of the cage are the gamma-gamma tubes that are used by Caltrans for the testing of pile integrity. From here, the cage will be lifted over and above the rotator, actually centered over the casing, and then slowly lowered down through the rotator's casing to the bottom of the drilled shaft. Note the 4 pad-like feet on the bottom of the cage. As it emerges from the storage hole, these feet enable the cage to stand upright on the bottom of the hole on the previously placed grout pad. These bottoms vary in depth, but some are over 300 feet deep. Ever so slowly, the huge cage is swung towards the cleaned-out drilled shaft. As said before, the cage has to be stabilized and centered directly over the hole before being lowered. Slowly, the cage descends into the cleaned out drilled shaft with the workman checking the ties on the casing. Here you can see the full length of the cage as it is held aloft. As mentioned earlier, one of the problems here at the bridge site is that everything has to come in by barge. Here they come, the 4 to sometimes 6 concrete trucks on a barge. As the concrete is pumped, the water that was used to charge the hole has to be removed. These men are hooking up to a large suction pump to pump off this water. Then the concrete is dumped from the concrete trucks onto a fast-moving conveyor belt, which carries the concrete to the pump truck, which then pumps it into the shaft. As the concrete is being placed, the sectional rotator casing is removed, one piece at a time. The same procedure is used on a 12-inch trimming pipe. The powerful rotator has no problem extracting this casing string. However, at this point in the operation, the operator of the rotator must be extremely vigilant so as not to let the casing string slip when he resets the gripping jaws. There are 2 sets of clamps, upper and lower, which grip this casing. Special care must be taken. This last section is about to be removed. The quick release lifting points are attached to the casing. The casing is then lifted clear. The casing will be moved to the storage barge nearby. Once the pile is completed and allowed to cure, it will be tested for structural integrity. This process will be repeated over and over until all piers are completed.